for all of us. We don't know yet about the final. So basically, this is something that nobody knows, has an answer for yet. We'll see, maybe we'll do it on Moodle, maybe it will be canceled, who knows? Yeah, it's still very, we're still investigating as a university how to deal with this. Yeah. It's a lot of stress, I know, but try your best to, we have to keep going, and we're here for you, yeah? So please send me emails. You can Skype with me if you like, and on Zoom. Just find me on Skype if you want, add me, and then we can talk at any point of time. So we'll do this together, yeah? How can we eliminate the repetition after we did the union? Let's try it out. Okay. So let me just wait for everybody to join. I think we're good. Okay. So we did the query, right? Select. We said, okay, to select all the information about all the people who are dads or moms, I can do also join and then do a union. But the union would repeat things. So how can I make it distinct? I can use the distinct keyword. Select distinct name, age, income.
Sir, can you please share the screen?
Ah, yeah, sure. Sorry. Okay, share screen. Share. Can you see it now?
Yes.
Yes.
Very good, very good. Okay, so select distinct name, age, and income from father, child, comma, person. Select distinct. Remember the distinct keyword, which gives me distinct values, age, income from mother, child, person, where mother is equal to name. And then if I run the query, I get Frank, Greg, Steve, and Lisa and Mary. So only the moms and the dads, and everyone only once. Okay? This is clear? Good. Okay. Okie dokie. Here I'm just using aliases. The only difference is I'm using aliases, but you don't need to do it if it's clear, if it's obvious what the attributes. There's no confusion in the attribute names. Right, guys? We can also negate the operators in and exists. Right? So we can say not in or not exists. So let's say I want to find people that have no children. So I want to find the people who have no children. How do I do this? I know how to get the people who have children. We've done it in various ways. Let's find people who do not have children. So basically, they do not exist in the table father, child, or mother, child. So one way to do it is to say select. Where name is not in, exactly. So select asterisk from person, where not in, select father from father, child. Then and or I want to now do the same, but not in mother, child. So is it and or? And, right? I want it to be not in father, child, and not in mother, child. Yes. So and name not in, select mother from mother. That would give me all the people who have who are basically non-parents. If I run it, look at the results. I get the people who are non-parents: Andy, Kim, Mike, Phil, and Rob. These are the ones that are not in father-child or mother-child table. Okay, let's do it with there exists. So I can say select h from person where not exists. And I say not exists what? Select father from father child, or h from father child where name equal to father, and not exists mother from father, mother child where name equal to, yeah, so it should give me the same results as this. It should give me Andy, Kim, Mike, Phil, and Rob. I run it. Andy, Kim, Mike, Phil, and Rob. Okay, that's the query in the slide here. Yeah, so we're using the where not exists. Again, this, you take every record here, substitute the name from this record in this inner query, execute the inner query. If it returns something, then this is false because not exists now. So this would be false and I shouldn't return this record. So if it happens that this person is a father, this subquery, the blue one, would return a record, and so this one should not be returned because he is a father. The same thing for mom. Questions? Good. We're recording, right? Let me see. Okay, I hope we're recording. Yeah, we are. Okay, good. Okay, good. Right. Let's think about this exercise a bit and then we'll do it together. So we want to find the name and age of mothers whose children are all at least 18 years old. What does this mean? I want to find basically for every mom, so I want to look at the table. The table mother child. And for every, only return the moms whose children, all of her children are adults, above 18 years old. Yeah, so basically I look at Lisa. Now I know that her children are Mary and Greg, and I want to find the ages of Mary and Greg and make sure that they are both above 18. If they're both above 18, then I should return Lisa. If not, then I should not return Lisa. So if one of them, even just one of them is below 18, then I should not return Lisa. Yeah, so all of her children must be 18 years old or older. Okay. So we're gonna do this in 3 ways. So using nested query with the all operator, nested query with the minimum aggregation, and nested query with not exists. Okay. Let's see the first one. So here's what I'm doing. I want to find the name and age of the moms. So I'm gonna do just a join between mother, child, and person, where mother is equal to name. That gives me names and ages of all the moms. Okay. Now I don't want all the moms. I want only the moms whose children, all of them are 18 years old or above. So basically, I'm gonna say and, right? There is a selection, some filtering. 18 is less than or equal to all. So basically, whatever comes here as a list of values, have to all of them be greater than or equal to 18. Yeah, this is what 18 less than or equal to all means. What is the blue query? What is it doing? It's selecting the age from mother, child, and person, right? Joining on the child this time, and such that, right, MC1.mother is equal to MC2.mother. Yeah? So basically, the record here, right? So it looks at every mom here that I've got, and then check the ages of her children. Get me a list of the ages of all of her children and make sure that they are greater than or equal to 18. It's a bit complicated. It's not very easy. We'll see an easier way of doing it. It's with the exists. With the exists becomes easy. Let's run it and see if it works. So I'm gonna copy it. Easier than typing it from scratch. And paste it here. Okay. Then go. And I get Anna, Anne, Lisa, and Mary. So all of them happens to be, so all three moms happen to have all the children greater than or equal to 18. Yeah, if you look at the table, now nobody here is less than 18. If we change the age a little bit, let's make it, for instance, 21 or 30 instead of 18. I should see some people, some moms filtered. Yeah, so only the ones whose children have age greater than 30. If I do this, I only get Lisa. Yeah, so Lisa is the only mom whose all her children are above 30. If you look at the table, why is Lisa the only result? Lisa's children are Mary and Greg. Both Mary and Greg are above 30. If you look at Mary, it's 42. Mary is 55 and Greg is 50. Okay, so both of them are above 30. So Lisa should be returned. Anne, would Anne be returned? Anne has children, Kim and Phil. Kim is age 30 and Phil is age 26. So both of the children do not make it, do not cut it, right? Kim cut it, but Phil does not cut it because we have greater than or equal. Okay, and then Mary, her children are Andy and Rob. So Andy and Rob. Andy is 27, Rob is 25, so neither of them are above 30 or 30 or above. So definitely Mary is not returned. Anne is not returned because of Phil. Phil's age is less than 30. We want the mom whose all her children are 30 years or above. No, if Lisa has one of her children, his age less than 18, you should not have it then in the result. Yeah, and that's what I showed by the example of 30. When I changed the example to 30, was to basically show that, right, some of the results will be filtered out because of this. Okay. Good. Let's do the same query with minimum aggregation. So what do we change? All we change is here, right? And instead of saying select blah, 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 where 18 less than or equal to all, I want 18 to be less than or equal to the minimum. Yes. So the minimum to be greater than or equal to 18, basically. Yeah, so we go here, we change the query from equal all to select minimum of CH. So get me Not more efficient, no, it's the same. Yeah, so again, right, yes, you have a point. It might be more efficient because the SQL query executor might execute this query only once and memorize its result. Yeah, so in that case, yes, it should be more efficient. Okay, so it's evaluating, it's comparing two integers, if you wish, rather than comparing, right, finding if something is in a list. Yeah, so it's, yes, definitely more efficient. Yeah. Okay, let's just verify that it runs. So here I'm selecting the minimum age of every of the children of every mom. So that's the inner query. Get me the minimum age of the children of every mom, and then making sure that this is greater than or equal to 18 or equal to 30. Yeah. So in this example, we change it to 30 to see that, right, not all the moms are going to be selected. So find me all the moms, their ages, such that all her children have, right, a minimum age of 30 or greater. So all of them are at least 30 years old or greater. Cool. Okay, and I get Lisa as before. Only one is Lisa. The Lisa is the only one who's, all of her children are above 30 years old, 30 years old or above. All right? Now let's do it. So this is the second way. The third way is to do it with exists. Okay, so let's think about it. How do we do it with exists? So again, I'm going to select name and age from mother, child, and person, joining on the mother this time because I want the name and age of the mother, and where not exists. Okay, select c.age I don't guess it, Stephanie. Where name? What do you mean by name? Let me show you how to do it, and then if it's not clear, please ask me again. Yeah. So select where not exists. Select c.age from mother, child, and person, where c.child is equal to c.name. So you're getting the age of the child, and mc.mother1 is equal to mc.mother2, and c.age is less than 30. Yeah? So basically, for every mom, right, check if there is any children whose age is less than 30. So for every mom, check, right, the age of the children. This query would basically return results if there is one child for a given mom whose age is less than 30. Yeah. So basically, I want only those people or only those moms for which this query returns no results. Meaning what? Meaning that all the children have age greater than or equal to 30. I run it. Okay, I have a problem. What is the issue? So I have an error. When name is not exist. No, it's where name not exists. Yeah. Line 4. Okay, let me see. Where? No, where not exists, select. It's correct from mother child. Let me see the slide. And I have to wear clothes here. Yes. And not exists, yeah? So where mc.mother, it's another condition, right? And I don't need another where close, another where keyword. And I get again Lisa, 75 is the only mom. All the children are 30 years old or above. I hope this clarifies a little bit what exists mean, what are all these right nested queries and how powerful they are. This is a good point to take some questions. If not, we'll continue. Okay. Okay, so typically the nested formulation of a query is usually more readable. So people tend to overuse them because they're more readable, they're easier to think about. It's easier to